Hello guys, welcome once again. In our lesson today, we are solving examples or questions on limit of functions and differentiation. On the board here, I have evaluate each of the following. The limit of this function as s approaches -2. The limit of this function as s approaches 5. Now, normally, when we are dealing with polynomials, it is easier to apply the direct substitution to get the limit of the function. But when you have functions involving denominators, we need to check whether to apply the direct substitution or we need to factor first. So with this, to do this, we have to make sure that the denominators of these functions are not equal to 0 when the limit points are inputted in it. Okay? So 2s squared minus 3s plus 2 should not be equal to 0 if -2 is substituted in it. So let's check. 2s squared minus 3s plus 2. I want to put in -2 where x is. All right. So this is giving me 2. 4, -2 to the power 2 gives me 4. This gives me positive 6 plus 2. 2 times 4, 8 plus 6 plus 2 giving me 16, which tells you that -2 is a domain of the function. That is why we are not getting a 0. So with this, we can now use the direct substitution in getting the limit of the function. So lim x to the power 4 minus 2 all over 2s squared minus 3s plus 2 as s approaches -2. So as I said, we apply the direct substitution. Wherever s is, we substitute -2. So x is going to be -2 to the power 4 minus 2 all over 2, -2 to the power 2 minus 3, -2 plus 2. All right? So -2 to the power 4 gives me 16 minus 2 all over 2. -2 to the power 2 will give me 4. You know, when we tried -2, all this gave us 16, isn't it? But all the same, let's check. So this is giving me 4, positive 6 plus 2. All right? So 16 minus 2 will give me 14 all over 2 times 4 giving me 8 plus 6 plus 2 will give me 16. All right? Then I simplify, giving me 7 over 8. Hence, the limit of this function is 7 over 8. So lim x of 4 all over 2s 2 3x plus 2 as s approaches -2 should be equal to 7 over 8. All right, so now let's come to the next question. Here we have x minus 5. The denominator have x minus 5. So as this denominator, when we put in the limit point, should not be equal to 0. Otherwise, our function is undefined. So let's find out. If I put 5 into x minus 5, I am going to get 0. Okay? So this tells us that we can't use the direct substitution. Okay? We need to factor in first so that we can now apply the substitution to get our limit. So if I have lim s squared minus 6s plus 5 all over x minus 5. When we factor the above equation, which is s squared minus 6x plus 5, we'll be getting x minus 1 and x minus 5. All right? So the lim x squared minus 6s plus 5, when factorized, we are going to s minus 1, s minus 5, okay? All over x minus 5. All right? So here we can easily strike out s minus 5, which is going to give me the lim, as s approaches 5. All right, so lim now gives me s minus 1 as s approaches 5. So here we can now apply our substitution. Where x is, we can put in 5. So this is going to give me 5 minus 1, giving me 4. So the limit of this function is 4. So the limit of the function as s approaches 5, s squared minus 6s plus 5 all over s minus 5 should be equal to 4. Alright, so we move to the next question, which says find the derivative of f of x equals to 2s squared plus 5s using the definition first principle. Alright, so the derivative of a function tells you the change in y with respect to x. Okay, so to find the derivative of the function, it is given or expressed as f prime of x, which is equal to f of s plus h minus fx all over h. Okay, so this is the formula that is helping us get or find our derivative of the function. So here we have f of x giving us 2s squared plus 5x. All right, then f of s plus h will be equal to what? So here s plus h is equal to x. So wherever we find x, we substitute in s plus h. Okay, so we are going to get 2x plus h squared, okay, plus 5s plus h. Good. All right, so now we can now put in our new expressions. So f of s plus h is given as this now, is equal to this. So 2x plus h squared plus 5s plus h minus f of x. Okay, so this is f of x giving us 2s squared plus 5x. All right, also in bracket. So now let us remove the bracket. Okay, expand. So this will give me 2 f of x equals to 2x, sorry, so we have to solve for s plus h to the power squared, giving me s squared plus 2hx plus h squared, okay, plus 5x plus 5h. This is minus, so minus 1 times 2x squared. You have to be careful about your operation. Minus 1 times 5x, okay, because negative 1 times 2s is negative 2s squared. Negative 1 times positive 5s gives us negative 5x. All right, this is all over h. Okay, so f prime of x, 2 times this is going to be 2s squared plus 2 times 2hs gives me 4hs. 2 times h squared will give me 2h squared plus 5x plus 5h minus 2s squared minus 5s. I hope you are following. Okay, so here we need to simplify, okay, group like terms and see what we can get. So you realize that 2s minus 2x will go away because 2s minus 2s is 0. So this will go away. Now I have 5x minus 5x also going away. All right, remember this is all over h. Okay, so our new expression is going to be 4hx plus 2h squared, right, plus 5h all over h. Okay, so now what do we do? Let's substitute for h. So h is what? 4x plus 2h plus 5 all over h. Now mind you, in all these things, h approaches 0. Okay, sorry, you have to be mindful of that. H approaches 0. All right, so what do we do? S will cancel, h will cancel h. So our new expression is going to be, as h approaches 0, we are going to get 4s plus 2h plus 5. Okay, where h is approaching 0, so we can now substitute h as 0. Okay, so therefore 4x is going to be 2, 0 plus 5, which is going to give me 4x plus 5. Wow. So our derivative is 4s plus 5, the derivative of this function. Okay, when you use the formula f of s plus h minus f of s all over h. All right, so this is where we end